Hi students, this section is working with probability and odds. So in this section we do have a few definitions and there are quite a few examples given different probability situations that you're going to need to know for this section. So the first slide here is talking about some definitions. The first one is the probability of an event is a measure of the likelihood that the event will occur. So the example below shows a visual of how probability is factored. So it's on a scale from 0 to 1. 0, it's impossible for it to happen. Then we look at this at increments of jumping by 25, 50, 75, then to 1 whole, which is 100. So 0.25, that's unlikely to occur. If we're in the 50 mark, that occurs half the time. 75%, when the probability is about 75, that's quite likely to happen. And when it's 100% occurring, then it's certain to happen. So outcomes is the different possible results. Example, when an experiment has 4 outcomes, the probability associated with each outcome would be 1/4. An event is a collection of outcomes. An example of that would be if you have a dice, when an even roll consists of 2, 4, and 6. So outcomes working with like quarters of the outcome. Events is something that a collection of outcomes that you have. Another type of probability we'll see here is theoretical and experimental. Theoretical is calculated by the following rule: the number of favorable outcomes out of the total number of outcomes. Next set of definitions, we have here experimental probability. This type of probability is based on repetition of an actual experiment. So the number of favorable outcomes observed over the total number of trials. That would be like flipping a coin. If you flip a coin, let's say 10 times, the total amount of heads you get out of the 10 flips you do. Also in this section, we're going to look at odds, the odds of an event. That's when all outcomes are equally likely. The odds that an event will occur are given by the formula below. So that's the number of favorable outcomes over the number of unfavorable outcomes. So there are a lot of definitions. So we're going to now look at different examples based on these definitions we just talked about. So example number 1, it says, using the results of a student lunch survey, you determine that the probability that a randomly chosen student likes green beans is 0.38. So that's about 38%. Is this probability theoretical or experimental? Well, this situation is going to be experimental. Why? Because you're taking the number of favorable outcomes observed over the total number of trials. So that's why it's experimental. The next example, it says, find the probability of randomly choosing a red marble from the given bag of red and white marbles. The number of red marbles is 8 and the total number of marbles is 40. So the way we're going to set this up is red marbles over the total amount of marbles So that's going to be 8 out of 40. And then when we get the decimal form of that, that's going to be 0.20, which is about 20%. 20% probability taking place right there. Example 3. In a group of students, 12 ride the bus to school. 8 are driven to school, and 5 walk. One of the students is chosen at random from the group. What is the probability P that the student walks to school? So our probability of student walking to school over the total number of students. So we're saying 12 ride the bus, 8 are driven, and 5 walk. So when we add that all up, 12 plus 8 plus 5, that's going to give me a total of 25 right there. So I'm going to solve this, 5 over 25. And the decimal form of that is, again, going to be 0.20, which is 20% there. And that'll be my answer. Example 4, here we're given a chart. It says use the circle graph to show the responses of 500 teens, that's the total, to a survey asking where would you like to live? If you were to ask a randomly chosen teen this question, what is the experimental probability that the teen would say a large city? Well, looking at the graph, we're going to find the large city, and that's 155 students want to live in a large city out of the total 500. So we're going to set this up as 155 over 500. And when we simplify this down and get the decimal, that's going to be about 0.31, which is 31% of the teens, want to live in a large city. Okay, we have 2 more examples here. Next example number 5, finding the odds. So here we're going to look at odds of an event. You randomly choose an integer from 0 to 9. What are the odds that the integer is 4 or more? Does that mean you can include 4? Yes, you're including 4 or more. So the setup of this, finding the odds, is the number of favorable outcomes out of the number of unfavorable outcomes. So we are looking at numbers 0 through 9. So favorable outcomes, that's going to be 4, 5, 6, 7, 8, 9. How many numbers is that? That's 1, 2, 3, 4, 5, 6. So that's 6 over. The unfavorable numbers would be 0, 1, 2, and 3. We don't count 4 because 4 is considered a favorable outcome. So that's out of 1, 2, 3, 4. So that's going to be 6 out of 4. Can we simplify that? We can. To simplify that to 3 over 2. And that would be my answer for the odds of that event occurring right there. Last example number 6, it says the probability that a randomly chosen household has a cat is 0.27. What are the odds that a household has a cat? Well, the setup of this is odds equals the probability the event will occur out of the probability the event will not occur. So the probability event occur is 0.27, our top value. Now we set this up as 1 minus the probability the event will occur. Why is it 1 minus? Well, 1 is representing 100%. So we take 100% and minus it by the percent or decimal, the probability the event will occur. So when we set this up, we have 0.27 for my numerator. 1 minus 0.27 is 0.73. So that would be the setup. So that's going to be 27 out of 73. And that would be my answer for example number 6. That is it for probability, and we'll continue talking about this in class.